Isaac Newton discovered much of what we know today about motion. What exactly did he give us?
Force is equal to mass times acceleration. So with the same force, the smaller body accelerates a lot faster, and the larger accelerates a lot slower.
As you can see, the cart with less mass moves a farther distance because it has less inertia, and the cart with more mass moves a shorter distance because it has more inertia. Now, join historian and science expert Victor DeBosch as he explains the fundamental rules that govern motion.
If I fire a gun, the explosion of gunpowder not only pushes the bullet forward, but Newton's third law also states that there will be equal and opposite force back on the gun and it kicks. Of course, the gun has a lot more mass, and so it experiences a lot less acceleration than the bullet.
A History of Motion, only on National Geographic. Galileo. Many people know about him, but not as many know he has a career outside of celestial bodies. Here is science professor Walt Craftsman to explain how Galileo took the world from flat and tilted it on its side.
Notice how the more I tilt a ramp, the faster the car moves. Galileo did this experiment hundreds of times. His conclusion, the steeper the ramp, the faster the object on the ramp would accelerate. He also discovered something else. The smoother the object's surface that the object was sliding across, the faster the object accelerated, which we're replicating by having a sliding object versus a toy car which is on wheels. Galileo is the one who discovered friction.
The following preview has been approved for all audiences by the Motion Picture Association of America. The film advertised has been rated PG-13 for martial arts violence. What's his move? Does he have the 7-2? That makes it straight.
Check.
I guess I was lazy.
I'll call you bluff.
Pair lines.
Ha! Fools. I got the high straight. Charlie, you might want to work on your poker skills, man.
Oh,
Stop gambling all of your money away.
it's only a week's time.
Charlie. Mathematics is the language in which God has written this universe. Maybe try looking at the probability.
Galileo said that one.
I'm good at math like that, Mr. McHugh, and I'm more qualified within the science field.
Oh, yeah.
Someone once told me genius is patience. The key to this is patience.
You're all set.
So, Bob, how was that last case you guys solved?
Whoa, what? Hey, talk about this thing. Such as classified information, Mr. McHugh.
Yeah?
Charlie, it's not that big of a deal. It's okay.
Come on, man. Like, I'm your friend. You can trust me. Hey, you remember last time at the wedding?
Fine. I guess we can say some things about this case. And like all of our great cases in which we have solved, it can be explained with business. Not in this. Okay. See, unlike your normal case, which tends to be murder mysteries or CEO assassination as of lately,
Yeah?
this one was just a simple museum heist.
Oh, really?
Okay, fine. Guess what?
What?
Just gonna have to tell you more about this lengthy story.
Well, okay, I'll start here.
Whoa. I've been doing the talking so far. I'm gonna tell this great story. You see, it all started on a Saturday afternoon.
You got a new case.
What's it about?
It's a museum heist.
Like one of those really big complicated physics-aligned ones I've been waiting for?
Nothing defies physics, kid. It's just forces in motion.
Like Newton's first law, that could maybe not.
Alright, kid. If you're gonna learn, you might as well learn right. This job, it's all physics. Now, tell me, what happens to an object when it stays in motion?
An object, when it's in motion, will stay in motion unless acted upon by another force.
Good. Because this crew, they're counting on everything stopping exactly when they need it to. However, that's not how the world works.
Alright, kid, walk me through it. How do you think they pulled it off?
Well, I would have to say it started at the main entrance to the museum. The thieves needed undetected entry. They waited for the guard to open the door, and then when the door was in precisely the right motion, Robber 1 slipped in.
That would be an application of Newton's first law, inertia.
Ooh, right! The door kept moving for long enough because of its inertia to let them slip in. Then they didn't have to worry about the guard hearing the door open.
What happened to the guards inside the museum?
They never saw it coming in the dark. Give the old-fashioned 1-2, he was out cold before he hit the floor.
Guessing from the damage on the guard, the blow was struck with the mallet. A standard mallet weighs about 0.33 kilograms, accelerating at 5.2 meters per second squared. It would be equivalent to around 1.7 newtons of force. That against a 2 kilogram head accelerated by 250 meters per second squared, far more than what you would need to knock someone out.
Once he got inside, he lets his friend in, and that's where we get 2 robbers. Next, they are faced with motion detection lasers. So, Robber 1 dodges and leaps through them to access the diamond. He vaults over the counter.
Newton's third law. When the thief vaults over the counter, they push down with a mass of around 80 kilograms, times that by gravity of negative 9.81 meters per second squared, makes his weight about 784.8 newtons. The counter then exerts an equal and but opposite force, keeping him up, a perfectly timed push forwards right over the obstacle.
But sadly, this leaves Robber 2 alone, not as athletic, so this thief makes up for it with his brain power.
He goes and enters a secret code into the panel on the wall. This deactivates the lasers. All remaining now is the prize they have all been waiting for, a big reward, a grand 1,000 carat diamond.
Well, but this is where things get interesting, Mr. Rob. They need to break the glass surrounding the diamond.
Let's see, a hammer goes from about 15 meters per second to 0 in a quarter of a second, with an acceleration of 60 meters per second squared, with a mass of 0.33 kilograms. Force would be 19.8 newtons. The clawed end of a hammer has a surface area of 4 millimeters squared. Total pressure would be 1.5 newtons per millimeter squared, or 220 psi.
Remember that in Newton's second law, you have to factor in acceleration. Since the end of the hammer slams to a stop in a fraction of a second, it has a huge amount of acceleration, and therefore a huge amount of force. That force concentrated to a point shatters the glass. And then finally, after they have recovered this diamond, they make their great escape.
Newton's first law, an object in motion stays in motion. Once the thieves got their momentum going, their inertia kept them moving through and out a window. For a window at a height of 3.3 meters off the ground, the robbers' bodies accelerate downwards at a rate of negative 9.81 meters per second squared. So they will have about 0.34 seconds to tuck before impacting the ground with a force of 784.8 newtons.
So, is this how it all went down?
Yeah, I mean, just sadly, it seems that this is not physics-defying and complicated. It just wasn't a normal bank robbery.
Well, this was found at the scene of the crime. The ID doesn't belong to either of the two robbers.
Well, I guess there's a third robbery. Maybe this is going to be more complicated. Let's go. Okay. Let me solve. It happened on a Saturday morning.
Our third robber was cooking eggs. He drops the eggs into the pan per usual, and due to the all-great force of gravity, the egg accelerates through the pan at 9.81 meters per second squared. Being dropped from a height of around 0.31 meters, it would take about 0.17 seconds for it to reach the pan, having a final velocity of 19.37 meters per second. Just before coming in contact, it will impact with a force of around 0.638 newtons. Oh, and let's not forget, it does crack due to Newton's third law, friction-reaction, where the force of the egg, when exerted in the pan, experiences an equal but opposite force. This 0.638 newtons can't be handled by the egg and cracks. Oh, and also, he doesn't just have eggs, he has an entire...
Sorry. What does this have to do with the case?
Okay. We'll fast forward a little.
That evening, approximately 1 hour and 35 minutes before the heist, the robber runs to get in the getaway driver's 2-axle fully drive manual 6-shift Jeep with 4 customized planetary gearboxes, perfect for a getaway vehicle. The getaway driver, let's call him Stuart, peers out of the third robber's driveway to go pick up the other robbers. Oh, and on the way there, like perfectly civilized humans, they listen to Beethoven. Back to Newton's laws. Once they get to the museum, Stuart slams on the brakes.
Because of Newton's second law, the robber has inertia and keeps moving even after the car stops. The robber flies out of the car through a window and rolls gracefully into the center of the room.
Perfect timing to give the other two robbers the hammer. Next, all 3 robbers open the box and then jump back out the window because who needs a door?
Like a good little getaway driver, Stuart is perfectly waiting at the bottom of the windowsill, ready to zoom off.
Little does that first robber know, he dropped his wallet during the little party ticket area.
Oh shoot, dropped my wallet. What? You dropped your wallet?
Newton's first law again. The robber still has momentum from the car with a mass of 80 kilograms moving at 40 miles per hour, or 1.9 meters per second. That's around 143.2 newtons, and unfortunately, he flies straight into a telephone pole.
Unbeknownst to the other robbers, he had the diamond in his pocket.
So he gets up and goes to meet with the boss.
And there you have it.
Now, do you really expect a robber to drop his billfold in the middle of a planned heist?
Okay, look, you're not adding anything to this conversation, so you left me to just create how I want to.
Well, let's take a closer look at the wallet over here. There was this.
My technologies?
The big crime syndicate.
Well, why didn't you tell me this at the beginning? Like, why did I get this?
The sheriff handed it to me personally.
What? That's not fair. I was left in the dark from the start of this.
I'm lead detective.
This just got a lot of times interesting, though. See, it is big and complicated. And we're gonna see how
Now
this
we know.
boss of ours is
Now
gonna
we know
react.
where the boss is.
Well, we better get going.
Yeah, no, tell him yes, I get that, okay. Yeah, of course you want, yeah, no, all CEOs are like that, okay. No, tell him I want him to raise the chocolate prices the week before Valentine's Day, so that way no one's gonna be able to pay for Valentine's Day.
Hey, boss.
Well, let's say we can take care of his
Hey,
family.
boss, I got you the diamond.
I'll have to call you back. What?
Got you the diamond you asked for. Here you go.
Let's go!
Hey, come on. He's got the diamond.
Whoa, that's kind of big. How's he even doing that?
Because his upper body has more inertia than his lower body, Newton's first law. He can quickly slide his feet across the floor, breaking sag friction, and it looks like he's running in place.
So strange.
Yeah.
You gotta be kidding me.
Frying pan.
Fifth time this week. Dang TV. Just it's the fifth time this
I
week.
see you're still funding the business, Alex Rye.
Yes, something like that. Are you that detective that keeps overanalyzing everything about physics?
This is a great Mr. Bob. And with that diamond I do, your alibi isn't gonna hold up in court.
Well, it's not illegal if you don't get caught.
But
Well,
we
we
just
just-
Bing bong! Frying pans. Who would known?
As you would have said, Bob, 10 newtons of force to a 2 kilogram head. So, doing some math, Newton's second law, it's about 5 meters per second acceleration, exactly what you need to be knocked out.
So, how did you two escape?
We did it. We partially did it. We took a little nap. Good study.
we woke up in a dumpster on the other side of town.
Wait, so what happened to the mob boss?
Dunno.
The FBI took all our files.
Wait, they took all your files?
No, just the ones from this episode.
What about the rest of the series?
The crime syndicate bought our company.